Hilchos Kiddush Hachodesh, Perek Tez Zayin. This class is dedicated Li Nishmas Avram Yeshaya ben Tzvi Hirsch. As a quick introduction to this Perek, let's explain two English terms, longitude and latitude. We mentioned in the introductory class that Earth is a sphere. It's a ball. It has no top and no bottom, no beginning and no end. Nevertheless, for practical purposes, we speak of the North and South poles as being the top and the bottom of the world, and the equator as being the midpoint. With these marks of identification, we can now label whether a certain place is in the northern hemisphere or the southern hemisphere, in the top half of the world or the bottom half, above the equator or below it. However, obviously, these are very general placements. There's a more specific, a more detailed method to defining the precise location of any place on Earth. And that is what's called the lines of longitude and latitude. The lines of longitude extend across the world from the North Pole to the South Pole. And the lines of latitude circle around the world above the equator and below it, essentially dividing the big ball of Earth into many small sections. The lines of longitude become the geographic coordinates that give us the position east and west of any location. We can say this place is east of this line of longitude or it's west of that line of longitude. The lines of latitude, on the other hand, give us the north-south position of any location. We say this place is north of this line of latitude or it's south of that line of latitude. By the way, these lines of longitude and latitude also help us define the distance between two locations. If you want to know how far New York is from California, that's an east-west distance, we would use the lines of longitude. If we wanted to know how far Texas is from North Dakota, that's a southern north-south distance, we would go with the lines of latitude. The Galgal Hayomi, the invisible sphere that turns all of existence daily around the Earth, has the same orientation as Earth. That means its top and its bottom is also directly north and directly south, and its equator runs directly from due east to due west. So essentially, the lines of longitude and latitude on Earth can also be extended outwards and applied to the Galgal Hayomi. In such a way, we can define the east-west position of any object in the heavens by using the celestial lines of longitude, and we can define the north-south position of any object in the heavens based on the celestial lines of latitude. We can also use these lines to define the distance between two objects in the heavens. If two objects are east-west from each other, we use the celestial longitude to define how far they are. If they're north-south of each other, we use the celestial lines of latitude to define their distance. In the Rambam, longitude, in other words, the east-west distance between two objects, is called oirech, length. The celestial lines of latitude, the difference north and south of two objects in the heavens, is called rochav, width. With this in mind, let's move to the Perek itself. At this point in Hilchos Kiddush Hachodesh, we've made a basic correction to the position of the sun in the Galgal Hamazoles, as well as three preliminary corrections to the position of the moon. These brought us from the Makom Emtsoi, the placement of the sun and the moon on their own orbit, to the Makom Amiti, the placement of the sun and the moon on the Galgal Hamazoles as viewed by an observer on Earth. However, all of these corrections were longitudinal in nature. That means that after the correction, the sun and the moon would be more eastward or more westward of the place they originally were. However, when it comes to the moon, that Rambam teaches us in this Perek, there's also a latitudinal correction that has to be made. You see, the Galgal Hamazoles, which we use as the backdrop for the sun and the moon's path, is inclined, as we explained in the introductory class, 23.5 degrees relative to the equator. But only the sun runs directly along the path of the Galgal Hamazoles. The moon's path is actually inclined another 5 degrees relative to the Galgal Hamazoles, for a total of 28.5 degrees relative to the equator. In other words, only at 2 points does the moon's orbit run along the plane of the Galgal Hamazoles exactly. These 2 points are called in the Rambam the Reish and the Zanov. At any other point on the moon's orbit, it's either more north or more south than the Galgal HaMazolis. This inclination is called in Rambam Rochav Hayarech, the width or the latitude of the moon. That means the moon being more north or more south relative to the Galgal HaMazolis. This inclination could potentially affect the sighting of the moon, because the more northerly the moon is, the later it will set on the horizon, which means we'll have more time to see it after sunset. The more southerly the moon is, the earlier it will set on the horizon, and the less time we'll have to see it after sunset. You can see this demonstrated pretty clear in this slide. This is a picture of the horizon of someone standing in Yerushalayim. That means how far a person in Yerushalayim can see in the heavens. And you notice that the more northerly something is, the longer it'll take to get to the horizon. The more southerly something is, the quicker it'll take to get to the horizon. The faster it'll disappear. So if the moon is more north, we have more time to see it. If the moon is south, we have less time to see it. And so, before we can get to the true position of the moon, we have to correct that latitudinal difference. However, there's two steps to this process. See, if the moon's orbit would be stationary, in other words, the Rosh and the Zonov, the 2 points of meeting, would always be at 0 degrees and 180 degrees of the Galgal HaMazoles, then things would be fairly simple. We would know if the moon is at 0 degrees, no correction is needed. If it's at 180 degrees, no correction is needed. If it's anywhere between 0 and 180 degrees, it will have a northern inclination. And if it's anywhere between 180 and 360, it'll have a southerly inclination. But, as the Rambam teaches us, the points of departure themselves, the Rosh and the Zonov themselves, are moving backwards, as he says, which basically means clockwise, along the Galgal HaMazoles. So that at any point where the moon is on its orbit, it can either be northerly or southerly inclined. Therefore, when we want to figure out the true position of the moon, the first thing we have to do is figure out where the Rosh and the Zonav are, where the two meeting points of the moon's orbit and the Galgal HaMazoles are. Then we have to figure out how far the moon is from the Rosh, which the Rambam calls the Maslul HaRochav, the path of the moon's latitude, how far it is from the meeting point. And only then can we figure out the Menas Maslul HaRochav, the angular distance caused by the Rochav, in other words, how far the moon is inclined to the north or to the south. And after correcting that, we have the true position of the moon. You'll notice that the table that the Rambam gives us for this correction is built on 90 degrees, which means he only gives us the adjustment from 0 to 90 degrees, and based on that, we can come up with the correction for any other number. And that's because the distance of Rochav HaYareach is proportionate. 10 degrees is exactly the same as 170 degrees. They're both 10 degrees away from the meeting point. 30 degrees is the same as 150 degrees, because they're both 30 degrees away from the meeting point. So once you know the correction for a quarter of the Maslul HaRochav, from 0 to 90 degrees, you can apply that to 90 to 180, to 180 to 270, and 270 to 360. In conclusion, it's worthwhile to point out that this concept of Rochav HaYareach, which the Rambam explains in this Perek, helps answer a fundamental question. If at every Molad, the sun and the moon are aligned relative to a person looking out from Earth, how come there isn't a solar eclipse at every Molad? After all, the moon is standing directly between Earth and the sun. Rochav HaYareach is the answer. The Molad means that the moon and the sun are aligned on their longitude, but not necessarily on their latitude. And therefore, there's only an eclipse when the sun and the moon cross both longitudinally and latitudinally.